All right, welcome everyone to the follow-up for Advent of Code 2025. Today we are continuing off from day
Or
2. We just did day 1 already. So let's see how many we can catch up to. I think we're going to try to aim for day 2, 3, and 4, and we'll see how far we get.
yeah, hopefully, right. So this was our day 1. So we already solved it. We also come up with some workflow to do some LLM summarization of problems so that we don't have to digest it from the text, which we can do, but it will take more time, especially live, right? So I have this summarize problem, which is just calls LLM and summarize it, so that we can just go ahead and try to implement whatever the steps provided in terms of direct code for both parts. This is just our solution for part 2. It's just one line for parsing and just another line to come up with an answer for the first part, send it out, it was the right answer, another simple line of code to come up with an answer for the second part and send it out, right? And I haven't looked for other challenges. It's today already 3 more challenges already out. So this is gonna be, so day 2 is already out. It's called the Red Nose Report, right? So we can read the prompt. This is just gonna fetch the prompt, right? We can read the prompt itself, or we can just try the summarization again. We just feed it the prompt and say, okay, summarize the part 1 for us. Though I'm gonna crunch.
Can you make it read out the prompt to us while you're working on it in the background, like text to speech?
Oh, it's gonna be too distracting. I'm not
Okay.
want to.
Okay.
I removed that button. I had like, I don't
Okay.
know, and it's too long. I don't want someone reading it out. Okay, let's see. Let's see whether we can solve this one. All right. List of reports.
This is the
Should we try
summarized.
to?
This,
Should we also ask it to solve it?
so first we're doing this is the LLM summarization of the problem, right? Let's see if we can grok what it's trying to do. So
It's not
we need to
just
analyze
summarization, also like steps. It
some
also tries
steps.
to outline the steps, right? It's not even that shorter than the original one.
Yeah, I know.
So
Implementation outline. Let's just look at that part. So read the input for each report, check if the levels are using increasing or decreasing, validate the difference between the adjacent levels, return the count of safe reports. Okay, seems like a good plan. Let's try it.
yeah, that's right. So this is just how you can just fetch the input, right? Usually it's enough to just import it as a table. If you import as a table, you get just the numbers out of that string. Very convenient. So I guess that's what it calls a level. So right, or a report. I guess this is the report. All increasing, all decreasing, right? So they have to be ordered. Validate the difference between adjacent levels. Return the count of safe reports. What is the safe report? They should be all decreasing or decreasing.
Validate the differences. For each report, determine if the levels are either all increasing or all decreasing. Check the difference between adjacent levels to ensure they fall within the range of 1, 2, 3. Okay, let's get the LLM to output some code. Maybe that'll make more sense.
Yeah, let me just try it first. Let's try LLM for the more challenging.
I mean, this also shows the power of Wolfram, right? It's literally one sentence, like a one-word function that like gets you where you're trying to go.
Yeah, it's like I think this is the differences, and I guess they all should be all positive and between 1 and 3. I think that's the test,
Okay,
right?
I see. I see.
I guess the test is just this all true between just like this gonna. I think that's what. Oh, it's
What is the asterisk for there? There's a little star.
that's for the composition, right? So it's like it first for the each or report, it computes the differences and then checks whether all of them is between 1 and 3.
Okay. And the composition of that is either true or false.
And I guess that's gonna. But
Now we
what
need
about
the
decrease?
count of truths.
Yeah, and then I just count it.
All
So literally,
increasing or all
so
decreasing.
if I would guess, that would be the answer, right?
Okay, so that's
I just
your
tried.
that's your attempt.
Yeah, without like. Let me just read the whole thing. I don't want to answer incorrectly. Right. The unusual example consent.
Okay, so each report is 5 levels. Okay, so each digit is a level, basically.
All increasing or any to just differ by at least.
Okay, so if it's all decreasing less than 3, it's safe. All increasing less than 3. Oh, no. That's okay. Then the next one in that example is unsafe. 2 and 7, there's a jump of more than 3. Okay.
So it's either this or the reverse of that is
The
this.
reverse, the inverse of that.
Yeah.
So what
So
do
it's
we do?
like
Absolute or
you can
something?
do it like this is safe queue, right? So
Okay.
we can just literally do something like I think there's even a resource function. It's either this safe queue or reverse this safe queue. Oh, the
Interesting.
same thing. We got the same answer for some reason. Oh, not the reverse. It's already computed the difference. The minus of that.
Okay.
Yeah.
I see.
So that's
Okay.
right. So let's try that one. Yep. Good.
Oh, wow. Oh, nice.
Right. So part one is done. Let's do. So if you regulate the prompt now, it's gonna now contain the part two here.
Part
Right.
2. Okay.
Yeah. And if I run summarization and ask for just part two, it's gonna try to.
And by the way, this is the Wolfram LLM, right? The
Well,
actual.
it's yeah. It's OpenAI, but with some Wolfram quirks
Okay.
and tweaks.
In part 2.
Yeah. Then we done this one.
Okay, so there's modified criteria.
Handle
I
unsafe.
wasn't aware the advent of code has started.
Yes.
Just
Yeah,
Yeah,
we're
it's
on day
already
4.
seeing this.
you're already behind.
I'm
Fine.
4 days behind. Okay.
Yeah.
Oh, it's
Yeah.
actually free. We still
Yeah. All of them. All of my previous work had been with Python. So I guess the time I want to try with Wolfram language.
Yep.
yeah, why not?
All right, cool. So handle unsafe reports. Okay, so there's what has changed?
Write through each level and simulate the removal of that level. After removing level, check if the modified report is safe. Oh, it's like try to remove at least all one level, right? We only allowed to remove one, and then check whether it's safe or not.
Oh, okay.
Yeah, I guess it's very similar, but
Oh, how does
basically
that
the
make
answer
sense? So
from
that would only work if the first and last levels made the report unsafe. Because if it's somewhere in between, the difference is always going to be greater than 3.
let's just call this safe all, right? You can so that it looks nicer. So it checks for both directions. But now I think we should run this for all possible removals also, right? So it's something like any. So it's any of. So what would be the removals? Is it just like all subsets? No, not subsets.
All
It's
subsets.
gonna
Oh,
order it.
isn't
It's
quite
not.
hard.
I'm just trying to figure out how to make it nice and simple. Of course, I can do some straightforward thing. Just
maybe like enumerate subsets or something.
Well, we can use delete, right? Because delete is literally just removes the position at position n, right? And we just and the
Okay.
position will be position all the lengths. This is like the straightforward range length hash, right? Something like that. Also 0. That's it. Here just delete. Oh, forgot to get it. Make most. Okay. I claim this is the answer. Potentially. Let's try that one. And we can ask LLM to simplify it. That's correct. No. Okay. Let's read it again.
Too low. Interesting.
Let me read the original report without any summarization.
Okay.
No. Except if removing a single level for an unsafe report. Oh, from then. Okay. I was confused.
Only the unsafe reports.
Yeah. So we already like this is generates. So we can pick. I just make it nicer. This is our reports. Okay.
Mm-hmm.
Can also do it here. Simplifying the problem. So let's pick reports that are different with the safe differences, right?
Okay.
So that would basically be the answer to the previous question, right? But if we pick the false one, we only should do it for and count this, I guess. Why not? And also add this guy.
That's the same answer, isn't it?
Was it? Yes, that's confusing. So that picks out.
Can we see the unsafe reports? Can you print that out again? Just see what that looks like.
Like this. Right, this is here it's
So that's
decreasing.
hold on. So it's not just about the difference, it's also about okay, so in your test now, are you just enumerating what happens if you remove one level from each set and seeing if that turns it into a safe report?
Yeah.
Okay.
So this is like safe reports. This is not safe, right?
Okay.
So we go through not safe reports and do the same thing as we did above. We are testing one removals and checking whether they are safe.
And you're doing it as the range of the length of the set.
For some reason it generates. How many of those there?
And you count all that then end up being true. So 38 got turned into safe reports. Can we print those 38? Let's double check that they did actually end up being safe.
Yeah, we can just do this. Pick. Oh yeah. Whatever. That's clear enough. Those reports should be safe after one removal.
Yeah, so you can see by the first one that's not the case.
Why?
Because it goes from 6 to 8 and then back down to 6. So it's not all increasing anymore.
Or I can remove this one and be safe.
Oh, you're saying these are the ones that can be turned into safe with one removal. Okay.
Yeah.
Can you? Okay.
Usually it's just maintain that are either, right? Safe from the start to become safe after.
What do we actually need to return? Are we returning the total new count? What are they asking for?
Yeah.
What's the actual
Yeah.
question?
We're returning this. This is our original one.
37, 34, 31. Is this the exact same number we had previously? Maybe I'm hallucinating. Should we try it again? Answer is too low.
Yeah, we're already struggling. It's not a good sign. So that's an
Maybe let's print out also the unsafe reports that are left behind to make sure that we're not missing some.
okay, this is safe reports.
Okay, so those are the original safe reports.
Yeah, we can
Then we should have
eliminate this.
then we should have a made safe report or something.
Yeah. We also compute the unsafe one by just complement, I guess. Why not? Right, and then just if this is just unsafe. Right, we just do this.
Wow, now it's is it busy processing?
What? No, I'm not.
I think.
Still 38. I'm confused.
Can we print those out? Let's just have a look.
Yeah, let's debug this. Maybe I'm doing something wrong here. You spot the problem. Oh, hold on. Hold on. I know what's matter. I need to do this. Okay. That's what I've been doing wrong. I was computing the length for a different thing. Look, now it's greater than 2 by 2. Okay, maybe that should be right. Yes.
Okay.
So that was a stupid mistake. All right.
Okay. Well, it's pretty close. So there's only 2 difference there. Okay. Awesome.
All right. Oh, we can still. Okay. Any suggestions how to improve it? Because we do something stupid here. But yeah, well, I know.
Ask the LLM how it would improve it.
Yeah.
Let's try on the left hand side there since we got the box open. Or how does it work? Oh, you can open it right in the.
Yeah. Oh, let's try
in
this. Just brace yourself if anything crashes.
So,
Okay.
yes, yeah. Just a reminder, this is still a beta release right now, so we're pre-testing. So, question: this notebook assistant, can it actually modify the code directly on the right hand side, or it only is like chat? You need to copy paste it back.
It only chats and copy. You can should copy paste it.
Okay.
No, that's more constructive suggestions.
Yeah, I normally for this kind of stuff, I normally use the word elegant. So I ask it to modify my code to be more elegant. That normally makes the code a little bit
I
nicer.
like this.
Okay, that's more like, yeah.
Instead of safe queue is within range. It's more descriptive. Okay, just descriptions of true. Kinda.
That's breaking it down more.
I was hoping like this can be improved somehow.
Yeah, maybe ask for the last code block, is there a more elegant way to write this?
Yeah. can be made safe. Let me just ask it how to generate a list of single element removals. Something
Of
like
a
that.
set.
Or at least there should be like a resource function. It should have access to all the resource functions.
It should know what all the resource functions are, which is
They
pretty
have
powerful.
like yeah, because it's a RAG behind it. So they have a
Yeah.
vector database of all those things.
That's pretty cool.
So single element removals. Oh, that looks bad. That's like that's basically what I wrote. But maybe there's a built-in things. Yeah, but basically it's not a
Yeah,
big improvement.
it probably defaults to what it's seen the most examples of, right? So then table is kind of like the most generic or the most common thing that it's seen, maybe something like that.
Yeah.
Yeah. Okay, cool. Should we try the next day?
Yeah, let's try that. So insert dissection 3. Bam. So here's the prompt 3. And that's not bad. I'll just not summarize it. Let's just see what the input is. Oh gosh. All right.
Okay, so there's some program synthesis going on here.
Multiplication. Right. Need to parse it.
Yeah, so it's a parsing challenge.
Until the 4 highlighted. Okay, actually maybe it's looks nicer on the side. We don't see it.
Yeah, so for parsing challenges, LLMs would probably be a good approach. Just actually using LLM to do the entire thing. Just ask it to output the result given this challenge.
Let me pass the picture because it has some nice highlights on the side. If you do it like this, right? It's more readable. Well, it makes sense. We just have to parse the moves, right, from this. So it just should be a string cases business. So just move. Maybe there's some regex thing going on. Should we try the regex? So I think you can do it like this. So it's a digit. It's a single digit, so I guess that's fine. And we put it brackets. Do it like this. I think you can do it like this. I don't remember my regex.
Does
I
anyone
think you
remember
can
their
do it like this. I think it works, but no. Let's check the documentation. I think you could have used $1 to parse it. Maybe. Oh yeah, it's not the dollar. It's just one. I need to find an example. It actually does this. Or do I have to like do double slashes? I guess. Yeah. Yeah, I guess maybe that would. No.
Yeah, we should remember to share this notebook afterwards, by the way, so we can add it to the YouTube.
Yeah. Sure. No, it's not one digit. Why did I read that? Has to be one digit. No, it's still wrong. Why is it not parsing? Help!
Sounds familiar. How about we output what this is? Can we? Okay, let's classic troubleshooting. Print statements everywhere.
There's no print statements anyway. We're just writing a regex. There's nothing to print.
No.
It's just like, oh, okay. Let's just forget about regex. You can write it directly by. Maybe it's more easier to do it like this. Right. Something like digit character, and then comma digit character, and close the bracket. And we call this x, and we call this y. Now let's try to get the cases. Okay, it worked.
All
I guess we
right.
also do the interpreter. Now those are the integers, and we just multiply them. What to do? Then what?
Add
Just
up all
add
the
them.
results of the multiplications.
Yeah. So I guess that's the answer. That's the first part of the first problem. Let's post it. Good.
Oh, nice. Okay. Regex leading us astray.
Writing a correct regex is the homework of the viewer.
Okay.
Maybe it has to be like something global. All right, I think we need to specify some global parameters, right? Because it tries to just find the one like this, right? So weird, even though this kind of works.
Interesting.
If I just try move, it works. Right, this one. What's the parenthesis? What's wrong with the parenthesis? Oh, you have to do it double. Maybe that. Okay, that was the problem, I guess. Put this, and this. All right, that worked. So I guess
Okay.
you can do this, right? Or you can multiply it. You can do this. It's not gonna be parsed, right? Because it's a string. So right. The interpreter. Just timed it. Yeah, that's another way of doing it. I think it's slower because what? It didn't parse. Weird. We just do it like this then. This is listable, if I remember correctly. Maybe not. I'll map it times. Okay, it's not that much better. Come on, what am I doing?
Is that a number? What is that?
Yeah, I'm confused.
We should have done this as a second attempt instead of overriding the original that you had in there.
Yeah.
Can you remember the original code?
Well, I'm not overriding. It's still there. That's my.
Oh, it's there. Okay, great.
Yeah, don't remove that. Anyway, let's just read the second part.
Oh yeah, we still have to do part 2, of course. Okay.
Do instructions enables future move instructions.
Interesting. So do and don't.
Yeah. Put the screenshot.
Interesting. So that's conditional stuff now. Wow. Hmm. So this would be an if. So what is this? Is this like meta programming, or how would you call this? Like creating programs from string?
No,
It's
it's just
compilation, right?
it's just simple filtering. So if you like, yeah, we don't. Let's do this thing later. This is just parsing all the moves, right? But now we also add this do's and don'ts, right? That just they always like this, right?
Is it inside the bracket or is it the full bracket? Can we see example input?
No. Yeah.
Don't. What does it do?
Yeah, hold on. So burn the slide. So now we have those, right? Well, we can just make do the same thing here. So we multiply. We don't have to multiply. Okay, let's do it later then. Just do the list, just the parsing. We do turn. Oh, let's just basically do one something just for simplicity. And this with 0. Take on and off. Okay, so now we kind of do this. I have
Okay.
this thing, and we basically what this means we have to only multiply between 0, 1 and 0, I guess. So this is turned on, right? And until you turn it off, you multiply this one. Now this should be ignored.
Yeah,
Until this,
it's one again.
right?
Yeah.
Right.
But it's
And you
starting
again
enabled.
you
It's
assume that
not one.
you assume it start enabled, right?
Yeah.
Yes. So kind of can basically prepend one
Okay.
like this, right? And now just sequence cases. I just find everything. This is our moves. Everything between 0 and 1. Or
So what
can
is
also
moles underscore?
huh?
What is moles triple underscore?
Oh, it's a sequence, right? So now this is a we extracted all possible if I did it correctly.
But that zero is in there. Is that called a trunderscore?
What?
You know, dunderscore is a double
I don't
underscore.
know. I don't know. I guess you also have to do like shortest. Something. No? Why is it like trying to extract this guy? What's wrong with that? Or maybe that's better. Right?
Okay.
We filtered them all out. Now we can use our interpreters again. Only care about this. What? Oh, maps. Let's map them.
Triple at. That's a trat.
Or I could have just done it like after the case. Because if I just care about only the moves, now I can map this and do the.
And just as a reminder, the \@ that's application of a rule to every case or something like that, right?
Triple add, it's basically replace the head. If it's double add, it replaces the outer list. If it's triple add, it acts on this, right? So we'll multiply each of those individually.
Goes in there, and the \@ at the end of that line,
Yeah.
or was that \/ yeah.
What backslash?
Yeah, this map. Oh, it's the
This is
shorthand
map.
for map.
This is just maps over. So turning all the strings into integers.
Got it.
Right. And this is our answer, I guess. Right. So we should do the same thing. If you add up all the results of just the enable multiplication, I guess. Yes. So let's post this. No, you failed. That's pretty sad.
Yeah, it seemed like that subset of
Okay, let's think.
valid programs was a bit less than it should be. Because it looked like there was quite a lot here that were activated.
We're missing something.
Don't.
Oh, it's like this is don't, this is do. Right? We append prepended it just for. It's like it's enables, here it's disabled.
What happens if there's two don'ts in a row or two do's in a row? How does that affect your program? Does it just carry on? Like if there's a
There's
one
no
and then
I think it's guaranteed that there is no such cases. I think.
Oh no, there must. I think I saw some already. Right at the top, there's 0 and then another 0 before. Let me see. Let me double check.
No. No.
0.
But it would have just failed if we had tried to multiply it, because there would be maybe, hold on, if it's the case, then okay, let's see if this is actually, this is not a list.
See, like right there, there's a 0 followed by a 0 in the first sequence. Before that, there's a 0 already.
This one.
Yeah. Mm.
Okay. So just I see. I just wonder why it's shortest. I think shortest should work. Why doesn't it work? Right, why is the first case? No, because no, yeah. Why is it doesn't look like it's shortest? What the hell? Why am I using it correctly? How about this one? This one? It's not copyrighted.
Should we do something like take until? Is there some similar concept?
Let's write like this. Does this make sense? We allowed this to be one. I guess we missed that. Right, so we raise this. Now, when we do that, there are some ones are still gonna be there, but we just need to remove them.
But if you multiply by 1, doesn't matter?
Okay, now we might probably handle everything. Let's try it again. Okay.
There we go. Nice.
It was
Well
just
done.
like simple mistake.
So what were you doing? Can you just explain that one line there? So you're doing a leading underscore list or one. Is that what that is?
Yeah, kind of. It's an alternative, right?
Okay.
Alternatives. So this is the pattern that matches either this or this.
I
Like, for
see. I
example,
see. Okay. Yeah.
the integer or real.
Mm.
So here just because it's allowed to be one in there,
Mm.
we just enable it twice, so it's not gonna change anything.
Okay. Let's see if the LLM can do a more elegant version of this. Although I'm going to vote this is too complicated for it to reason about, especially because you have text in there saying do and don't. That's likely to throw it off. But let's test.
We just explicitly paste this.
And you're saying this does actually have the context of the whole notebook on the right hand side.
Well, some of it. I'm not sure. I don't know the details, but it knows about this notebook, right?
Okay.
And it's also like the sources button also includes it,
Oh,
and even
cool.
the messages. It's like
Oh,
it
that's useful.
it
Yeah,
generated some error there, so
that's
it also
very useful.
now it's included. I don't know.
Just breaking it up, basically.
Yeah, just breaking it up. So I wouldn't
Okay.
call this improvement.
Okay.
Only inreadability.
Yeah. Legibility. Yeah. Okay. Let's tackle one more day. Let's see if we can get it
That's
out.
the number 4. Serious search prompt. All right. I guess there's some labyrinths again. So it's
Yes, there's
like
a horizontal,
like
vertical, some kind of pattern stuff.
yeah, maybe we're gonna do graphs. I like to solve those with graphs. So there's some visuals coming up.
Okay, so you're trying to get to Xmas, and you can do it horizontally, vertically, diagonally, or backwards. So in that little example there, you have Xmas on the second line.
Mm-hmm.
You have Xmas going diagonally from the top down to the right diagonally. You got Xmas on the fourth line, and then you got Xmas going from the bottom to the top, starting on the line 5 going upwards. So those are kind of the different options.
Yeah, let's see how it actually looks like. Okay. Let's can I break it up? So if I do the characters and do split. Is it split by no kind of just do the string split first. String split of the new line. And then do the characters and do matrix form. I think it's so that
Really looks better.
yep. I'll just call this data. Right. Let's try it. How many?
Usually for these types of ones, you'd have an array, and then you'd increment, decrement x and y by 1 every time you start with an x, and then you'd kind of like do a search that way, and then you'd run a loop over that. But we can do stuff visually. Should be very cool.
Yeah, let's do this. I want just to look at it.
Can you make them in different colors?
Yeah, I guess.
Like if it's going vertical to a certain color, if it's diagonal, it's a different color.
Well, you have to find it first.
Yeah, you just find it. Yeah. So
And
here you just find it. first. Yeah.
This is,
Okay.
this is just letters, right?
Okay.
4 different letters.
So those are variations of orange. Okay.
Now let's try a different color function. Maybe.
Is there a Christmas theme?
Maybe there's a plot theme. Is there themes? Let's do
Christmas?
same
No?
marketing. Oh my god.
Okay.
Classic, minimal.
Minimal
Thank
sounds
you.
good.
It's fine.
Minimum looks multicolored.
I think it's the default is just without frame.
Okay.
We have to just specify our own. 1,
Okay.
red,
Red,
2,
green.
green, 3,
What are the Christmas colors?
4, black, white.
Oh wow, that hurts my eyes, but that works. Okay.
Green is 2.
It reminds me of those like 3D things that you used to squint at as a kid, and then it like made a dinosaur pop out or something. I don't know if you ever, I'm sure that gave many children vision disabilities. I actually needed glasses after those things became popular. Now that I think about it.
Anyway, so okay, is there like a built-in function that can solve it, or we just have to?
Just ask the LLM. Maybe start a new context, a new chat, and then say, "Is there a function that solves the classic coding challenge problem of patterns in a 2D array?" Yeah, let's see. I'm gonna do a LLM session my side here too.
Well, let's try this button. So there's a like nice inspiration button. I just started it, and I'm gonna say, okay, this is my answer.
Inspiration button. Oh, cool.
Well, it's a good intention, but there's no such function. No, right.
Yeah. I think the follow up here would be create that function.
Yeah. Well, okay, we can try it just pressing inspiration button, right? Like, okay, here I started writing one. Continue. Oh, that's hopeless. That's not even the definition. I was hoping it would write. Well, is it allowed to? It's allowed to bend, right? It's not. Oh, it's not. Only horizontal, vertical.
Diagonal.
Then
Diagonal is
diagonal.
allowed, I think. I think I read that.
Yeah.
Yeah, backwards. Also backwards. So, but is it backwards on one, only on the same line? No.
No, like
Backwards in
this
any-
one. Like this one
Yeah,
is back.
yeah.
Oh, it's a bit easier. I thought it also allowed to bend like X and then go down. XM and then AS down.
Oh, bending. No, I don't think bending.
I bet it is a part 2. I bet it's gonna be a part 2.
Okay.
You can already guess. But okay, the part 1 is not allowed to bend. I guess we can solve it easily. More easier.
All right. Still asking LLM here.
I'm going to just go on a limb and try this one without thinking too much about it. This is our answer. Whether it's correct? No. Also, I like to the end, so I have to think about it then. All right.
Is there a function called find pattern grid? Oh no, that's what we have to do. Okay, how about this? So here's a little generated function I got from my LLM. What do you think of this? This is like the classic way you do it. So you'd have directions, which are integer increments in 4 directions. So 1 0 0 1 1 1 1 minus 1.
First of all, close this. What is this? It's word. Is it like string? Why is it here twice then? Why do I put it here? Then it's the same one. Why should I fix it?
So it's a module. Obviously, it's encapsulating the parameters so it doesn't pollute the scope.
What is it supposed to find? This one. I don't like it already. I don't want it, but so like, let's start with like this is the good start. It's like a source function that just generates all 8 rotations,
Okay.
right? So essentially like all possible orientations: left to right, top, bottom, bottom, top, right?
Does it do diagonal as well?
All right. Yes. No. So maybe that's what what we're missing. So this is counts all the straight directions, right? So the diagonal, I guess we just have to extract the diagonals from the data, right? I think you can do it with band. So let's see how can extract the band. Is it used can be used with extract or just to create arrays? Never use that one. Or actually, you can just use maybe diagonal takes an argument. Yeah.
Oh, interesting.
Okay. So if you do diagonal, that's going to be the main diagonal. That's going to be like 1 off. This is like load direction. Take lists. No.
Do every diagonal.
Essentially, to generate all of them, we just do this.
Is there
The
a
dimension
way
is square, right?
Yeah.
Yeah. So
Is there a way to rotate a 2D array kind of like on its side so that the diagonals become the horizontal and vertical? Do you understand what I mean?
there's no point in
Do
that.
it. Okay.
Like we just call this diagonals. Essentially, just do it. There should be 2 of them. For this generates like diagonals like this.
Yeah.
In order to generate diagonals like this, you just need to reverse each row. So that's going to be all the diagonals, right? And you can, and this is all the rotations. So we can call transformations all these rotations joined with all the diagonals. Yes. I had to even patinate it.
It already looks like some of the strings are not right.
Whatever. Let's just, and then we just sequence count of this thing in all our transformations. Okay, get some number.
More, so
We
that's
just
good.
have weight in it in our skills. No.
Still too low. Okay.
Hold on, when we were missing, we also diagonal. We only counted diagonals like this and like this, but you also have to include reverses. Reverse goes.
Yeah.
Reverses. So there are 4 diagonals technically. So you have to do diagonal like this for this. Should we do it for all the rotations? For all the rotations like this, without including. No, it's
See, what I was thinking is if you could just rotate the array like
Well, that's what
45,
that's what it
90.
does. It's you do it but by version. This is gonna reflect it, right? But
Okay.
you also need basically you can just there are 4 reflections. There's like you don't do anything, you do the reverse, you do map reverse, and you do reverse followed by map reverse or something like that. So
Okay.
this is like all possible reflections, and we can just map it or whatever for all our data. Right, so this is our reflections.
Mm-hmm.
So we can let's do this, join it like here, and it's going to be our all possible rows. Maybe this is all possible transformations, right? Here we just flatten them, catenate them together. Okay,
Yeah, it's
now it's higher. Okay, I have faith in it again.
getting too high. Oh, okay. Gone under, now we've gone over.
Well, what can go wrong? Let's think
Can we
about that.
print out some of the what it's getting? That'll give us a hint.
Yes, we're just
Actually, should we try visualizing it? Maybe the visualization will
yeah,
be
yeah. That's we just take
interesting approach.
the same thing and just plot them. So this is all the
Hmm.
matrices. It's hard to see. We'll just get their example. Why not? This is our test.
Yeah, start there.
data.
Yeah.
Let's start with this test data. Right. Let's look like the same thing. Let's go test input. Then test data. Basically the same thing, but for the test input. Test input. Right.
Mm-hmm.
So that's how this one looks.
Okay, so what do we want? We want a sequence of each colors in a specific.
Oh, hold on. I forgot to do the diagonal. The diagonal. I rolled stupid thing here. I basically repeated. Oh, yeah. This is reflections. This already includes reflections. But I have to just take reflections and they generate the diagonal for each of those. We had this code and I removed it for some reason.
Oh, okay.
Right? Like something like I'm gonna write it.
Hey, Benjamin, have you completed day 4 yet of Advent of Code?
No, actually, I was stuck with day 4. I just came here for inspiration.
Okay, there we go. There's actually a function for that. It's called inspiration.
I was wondering if Mathematica probably has really nice things for matrices and diagonals and things like this.
Yeah.
See, there's something with diagonal there.
Yeah. It has something. We try to use as much as already exists there. It's like I don't like to reinvent the wheel. That's what like learning the language is. Just learn all the already present functionality. Don't write your own. Okay, so for all reflections we extract the diagonals like this. And join them, do this thing.
The diagonals and the reverse diagonals, right? You've got that as well.
Yeah, that's in all the reflections. Because we're computing the diagonal for all the reflections, I guess that's gonna cover all of those.
Okay.
Right, and this was too high.
Mm-hmm.
Is it lower?
1.5 something was too
Yeah.
low.
Okay, that's promising. So it's lower. Let's try that one. We fix that stupid mistake maybe. Now it's correct. Okay. Now it's complaining that we are stuck. No. Maybe we are stuck.
Okay, let's just use some logic here. So how many reflections do we have there now? Is that 12? No, what is that?
Yes.
Yeah, 12. So
We
horizontal,
were going to do
vertical.
it for the test data, right? To see how it looks like. So test transformation on our test data. Let's just see how it looks like. Right, and plot test transformation so that we see what it actually is doing. So I guess this is
Yeah.
the identity, right? So test transformation 1 should be the same as test data. I hope. Yes.
Okay.
Right. So that's the original. That's
Okay. So that reflects it along the vertical.
it's
It
a
reflects-
rotation. Rotation 90 degrees clockwise.
No, that's not a rotation. That's a reflection. Because if you look
This
at
is
the
rot-
sorry, no, you're right. Yeah, it's rotating it. Yeah.
Yeah, this is
Those are all the
another.
rotations.
Yeah, this is
Okay.
this is now a reflection. I guess plus this one, right?
Which way is it? It's reflecting of which one? That one. Okay, it's reflecting of that one. You've clicked there. Yes. The second one's reflecting the first one. The second one on that row is reflecting the first one.
Yeah.
This reflect that one on the number 4. And
Is it going to
last-
count something twice? Maybe that's why.
Well, so far it's unique. Let's
Oh,
look at
I
these.
know what's the problem. Diagonal K. It should go for minus this.
Yeah, aren't we missing some diagonals here? Because it looks like you're cutting out half of the options.
I think that's yes, I think so.
Yeah.
We were missing the minus diagonals. Okay, let's try this.
Because you rotated and then kind of like cut it in half or something.
I only took the upper half. I think I only
So you need to-
included that.
Yes, of course. Yeah. That's actually so obvious if you just look at the pictures for a bit, you can you can tell where it went wrong.
But now there are too many of them. No, that was already too high.
But let's visualize it first and let's make sure that it's capturing everything. Still half.
Well, now this is like both halves of the diagonals. Right? This is just if you look at the rows here, those correspond to diagonals.
Oh, I see. It's the
So how
full
many?
row.
Are we missing some? Yeah.
It still doesn't look like the right shape because that should be a lot wider than what it is, isn't it? That wouldn't make a square. That would make like a weird diamond shape if it was normalized. Or am I wrong? Like it doesn't seem like those
Oh,
boxes should be squares regardless of the shape of it. It should be a
The
square.
longest diagonal is actually.
They should be squares, not rectangles. Because it's 140 by 280, right? The lengths should
Well,
be the
just
same.
aspect ratio. It should look like squared. Just maybe aspect ratio.
Okay, that's good. But then,
Right.
Okay. But the count, why would 140 be? It shouldn't be longer in the vertical direction than the horizontal direction. It goes to 280 on the
Well, that's
Y.
well.
It should be 280 in both directions.
Okay. Hold on. Maybe I've done. Yes. Right. Should I divide by 2?
No. You're cutting off something, I think. I don't think you should be dividing.
I don't know. It's like basically here's an example. If I have a array 4 by 4, right?
Yeah.
When I use the diagonal, like the first diagonal, the
1, 2,
zero diagonal is the main one, right?
Yeah.
Then this is this thing.
Yes. Yeah.
This is 2. is this one, and the last one is basically this. So it's
Yeah,
not,
it goes
it's minus
next.
one, but
Yeah, but you're missing the bottom half for doing that.
yeah, but we also do from -1 and minus.
Okay, yeah. So that's isn't that what's missing here?
Well, I was going. No, it's correct. I was going. We're including some short ones, but it's fine. It should be fine. Right, because these transformations, when I catenate them, the last ones are some small ones. Yeah, there's just rows in those diagonals. I think that should be okay.
Minus length. Is this diagonal thing messing us up somehow? How do we know we're covering all? Should we just add 140 on one of the directions to move it like over? So that if we're enumerating everything, we're catching the half on the left hand side that's been cut off here. I still think we're cutting out half.
We're not cutting anything.
Oh, okay.
Just
I'm pretty sure
this triangle has the same number of elements as this thing. Right, you can do some area computation if you.
yeah. What you're saying is what makes logical sense now that I think about it. Wait, no, I disagree.
Yeah, why?
Because it's half of 140 multiplied by 280, right? What does
Yeah.
that give you?
Well, it's going to be 140 by 140. So the
That's-
same as this. So there's some other stupid mistake that we have.
19,600.
And I don't try and run well.
Should we try a different approach?
Oh,
Maybe
hold on a minute. Let's just go back into the beginning. So if you have a grid and you want to read out the horizontal direction, you just take the rows and count the sequences there, right?
Mhm.
If you want to compute the reverse one, you reverse the rows. So it's one of the reflections.
Yeah.
Right?
Then you have to reflect twice if you want to read.
If you want the columns, you basically rotate it, so it's like a transpose. And you do the same kind of thing again.
Yeah. Transpose reflection.
Then why there is 8 of them? Why do we
So
need?
that-
I think we're counting more than twice. We're
Yeah,
counting them.
We're doing too many. Of the horizontal and vertical, there should only be
Let's just do this
4.
false here. So if we only, I think this is just will only include
1, 2, 3, 4, 1, 2, 5, 6, 7, 8. There's 8. Okay,
right?
this
So
seems right. Okay.
maybe we just only need those, right?
Yeah.
Only reflections. We don't need rotations. Maybe rotations is for the second part.
Yeah.
I'm hoping we're just gonna for the second part just replace this false with true. Let's see. That's my guess.
Okay, we generalize too heavily. Okay, let's run.
Let's hope. Yes.
Hey.
Let's read the second part and see whether we just change false to true and it will solve it. Did you misunderstand this? I meant.
have to find masses in the shape of an X. That's a tricky one. Throw a curveball at us.
X dash puzzle. So okay, it's not the generalization also. In which you're supposed to find two masses in the shape of an X. Okay. So we have to find the square, the square pattern instead of a string pattern. But I guess the same kind of thing applies.
Yeah, so but also now you have to do the rotation of every way that mass can form an X. Well, yes, yeah. You can't just rotate the grid anymore because it's the X that gets rotated within the grid. Okay, in the example, there's 9 X masses.
So this M and S can be. Okay. So this. Okay. Fine. Let's try. So what? I think this kind of rotations are still useful. We just have to look.
Yeah, this might actually be even easier because you're just rotating
Yeah.
the search.
I'm gonna use some other resource function for that. I remember there's something.
For this one, you can just run a normal search, can't you? Just like top to bottom.
What do you mean normal search? We have to look for submatrix.
Submatrix.
Yeah, it's a bit. I remember there was a resource function for that.
There will be
We don't
1,
have to write.
2,
I don't remember the name.
3. So there will be 4 variations.
Block submatrix. It's actually Brad Clear wrote that.
Mass, Sam, mass, Sam, Sam. Yeah, I can count only 4 rotations on the ways mass can form an X. So we're just looking for that resource function.
Well, I found it. I just kind of having second thoughts. It's whether it's a good one.
Oh, okay.
It's like a performance wise, it's a pretty bad. We don't want to extract all the possible submatrices and then search for it, or should we?
Oh, I see. Wow, that's huh.
Some sequence count doesn't like go into two-dimensional thing, right? No way.
But it doesn't need to be two-dimensional. It doesn't need to be two-dimensional if it's.
Well, anyway, let's do it. Let's do it the stupid way first.
Okay.
So that's the fun. So that's just computes. So it's always 3 by 3, right? So let's see what it produces. It also produces some. Okay, so it's like offset, some black data. Guess what we need this block data thing. And we do it for all these rotations again.
On.
Right, so we do all block data. That's all blocks. Right, let's see what. Oh, it's a.
That doesn't seem right. Where are you specifying MAS? We're not doing that yet.
What is it doing actually? What's the keys there?
So these are all possible 3 by 3 subsets of the data.
What are there multiple? It's a non-overlapping. I see. It's not overlapping.
Oh, it's
There.
non-overlapping. Oh, interesting.
So for each, but do they have the same blocks? Or is it not? How many of those are there? 25.
25.
I guess, yes. Maybe that's what we need. So, okay. If we just do the block data and like concatenate it, that's going to be all dimensions of this. Hold on a minute. Oh, they're different, right? Some of them are just one. It's like a boundary, I guess. Something
Yeah.
like that. So I just do flatten 2.
But why does it go straight to from 46 to 1? Shouldn't the boundaries have?
And I just count. What are we counting? Essentially, like this pattern M A. Gonna write it like that. M A.
MAS and SAM. Oh, wait. Wait,
Oh,
how are
it's
we entering the pattern?
like a pattern, right? It's like this,
Yeah, so it needs to be.
right? Like this.
Yeah, and then S space M. Oh, no, you're right. Yeah.
Yeah,
So there's
we
4
count.
different variations of the pattern. There's this one, then there's the inverse of one math, inverse of the other math, and inverse of both. Because it can go backwards. I think.
Yeah,
I'm assuming.
what we write. Oh, so we are searching for this pattern. Right?
Yeah, that's the first one to search for. I think it can go in reverse as well.
No, it's the same. It's the same pattern. It's just rotated, right? So if you just search for this pattern for on all our rotations, this is just one rotation, but we do it for all possible transformations.
Okay.
Like whatever we did here, just do all the transformations. Oh yeah, it's can be 0. It's not applicable. Okay. Can we do? Or can what does it return if the matrix is too small? Or just complaints. Okay, it's not the function is not very general, but I think it's basically fine. Ignoring that, I just total this, right? And that I guess that's the answer. I hope.
Too high. Let's double check that. Let's double check that they do want all rotations. I might have misread.
I think the problem is that we can double count. So because of this pattern itself is symmetric. So we have to cut out some reflections. Right? Because if we're gonna reflect it, we're gonna count the same pattern twice. Right? Like because look at this pattern. If you just reverse the data, it's gonna be counted twice. And we don't need diagonals.
Yeah, no, you mustn't reverse the
we
data.
also
The
don't need
data.
diagonals. We also
Yeah, the
don't
data.
need any diagonals.
Yeah.
So all we need is identity. Reverse is not gonna be helpful. It's gonna be.
But wait, do we need to? Okay, are these reflections of the search term, right? Just the mass. We don't need to reflect the data.
What do you mean?
We only need to reverse. We only need to do the reflections of either the search query or the data, not both. Let me just divide 1834 by 4. That might be the answer. No, that's an uneven number. Never mind.
Okay. Maybe
Maybe about 2. Yeah, that could work.
I don't know. I'm not convinced.
Do you get more gold stars the less times you try?
No, I don't think so.
Oh, okay.
You can try. You can try. There's some delay, but I don't.
You don't get more points for number of less
No,
number
I
of.
don't have. No, I don't. You just have stars. If you solve it, good. Just don't DDoS them by answers. Okay, let's think about this. Tricky. It's tricky. So
What are you reflecting? So let's look at that. So there's the
I'm
pattern.
only reflecting like a left right, right?
You must
Because the
reflect up
pattern
down as well.
because the pattern is symmetric. If you just top bottom is reflected, it's not gonna change. We're gonna count it anyway.
Well, okay. So am I correct in saying that there's 4 patterns that we need to match? There's four options of how this thing can form a cross. Because there's mass, there's mass Sam, there's Sam, and there's Sam mass.
Oh yeah, hold on. Yes, you're right. Basically, we need. Let's do it like this. Yeah, let's just make 2 patterns, but switch M's and S like this, right?
Yeah, that's one.
And
Two.
one is
Yeah.
in just 2 sets of reflections.
Yeah, of both of those. Yeah.
For the first one, we
I mean, we can also at this
Hold
point
on.
we can also just like.
Right, so we do this one. So basically, we need to properly account for that. So let's just do map red. This is transform. Hold on. We have pattern 1, pattern 2, and also reflections 1, reflections. So and then we just come up this. Just do pattern and reflection. Let's do it like this. Search for the pattern and reflections here. Map data, something like that. I remove that thing from here and top of this. We don't need this anymore.
That's the same answer we got previously.
Really?
Yeah.
When?
I don't know. I wrote it down. I wrote 1834 down. So I don't know if we submitted it though.
Shouldn't the first button be MAS?
Yeah, I mean, at this point, we might as well just be explicit with all 4 patterns to make sure we're doing it right. Can you print out the reflection 1 and 2? Can you see what they look like?
Oh, you mean okay. So if we just have one pattern and we
Yes, yes.
instead do
Huh? Oh, no, I don't know if
we
those
don't
are.
transform our data but transform the pattern instead,
Yes,
right?
yes, yes.
And even rotations too. And just whatever they are, delete duplicate.
There-
Like this
Okay, now
this
let's
4
look at this.
pattern, right? So that's if that's our pattern,
Correct.
so you want me to just ignore is it called weird thing? So we just so this is the pattern.
Okay, I need to jump on another meeting. Let me know when you solve it. Okay, bye for now.
Okay, bye. Just do all the blocks separately. And then we just go, right? I guess. Hold on, that's the same answer. Oh,
Yeah,
and we already tried that, right?
yeah.
Well, it kind of makes sense because it doesn't matter which one you rotate, the data or the pattern. But what? Maybe this one is just doing something that I'm not expecting, like overcounting it. I just extract everything myself. I'm just gonna do it on my own. So if we want all the blocks 3 by 3 from the data, just I think that just partition works. Like something like this should be work. Let's try it. Why it's not this? Why do we using some source function? We just catenate. And this is all the blocks. No. What?
That's still low.
Oh, with offset, maybe need to add 1. Otherwise it's not overlapping. I think it got smaller. No, this is for the previous one. Whatever, I'm gonna just try that. Yes.
Oh,
Right.
okay.
So I just remove
Nice.
this stupid thing. And this. Yeah. All right. So that resource function confused me. Okay, and the 5th already is not out yet.
Yeah.
We can start the countdown. It's 8 hours. Yeah. That was a good one.
So the post answer and answer interfaces with the advent of code. So it directly posts the answer to their server.
Yeah. I'm doing it
Oh,
by
okay.
have this
Oh,
my
I see.
cookies encoded in this object. Right? I can share this notebook
Sure.
You can
That'd be
still use it.
helpful.
You have to replace it by your cookies from the side.
Yeah, I would like to see your day one. Well, I've done my first try, but I'm not sure if it's efficient enough using Mac thread.
Do you want what
Day
do you
one,
want part one?
day one, day
Oh,
one,
day one.
day one,
Because which is
day one.
this.
Okay,
You parsed it and it's sorted.
thread. Okay, I see. I used my thread. Okay,
You don't have to. This is just for parsing. Because
yeah,
if you have this list of pairs, right? You already just can use import string table to already produce this list of integers, pairs of integers. Then thread is just turns them into whatever this. It's the same as transpose.
to list. Okay,
Yeah, so they can assign left and right to it, and then you just sort that, and that's it. Yeah, and this is just using lookup.
so part two looks up for the counts for. Oh yeah, then times. Okay. Yeah. Yeah.
Just clean up. Just leave the summaries. I haven't tried to summarize this one. Oh, actually, the extra cool thing we can do. Let me get rid of this. It's to visualize all the patterns that we found, right? That would be nice. Let's do it. Like visual. I don't think there's a good candidate for the previous days that you can visualize. I don't think so. Multiplying. This is not very nice. So like you can kind of highlight it. How large is the string? Yeah, you can highlight it, but it's not that interesting. Is there a highlight string? Something like some nice highlighting of strings. Let me find. Oh yeah. Let me try some cool functions. Resource highlight text. Just do this. Does it support patterns? I would just, and let's try the same pattern. Oh, that's cool.
Mhm.
And we can magnify it, make it very small. 10%. Oh, look, it's fun. That's kind of visualization of sorts for the day 3. But for the day 4, we can also visualize this xmas
The bottom.
mass in x, all the x's, right? Because here just we have is there a way to find the position of the block though? Well, in a way you can do. We just partition it here. All our 4 patterns, but on the level 2, and we do position. This is the position of the blocks. It's kind of the position of the pattern in a way. You just have to add 1 to everything. Thread it. 1. I think that's positions. Catenate all of those positions. I think those should be the centers of all of those x's. So if you have a matrix, which is our data over here, whether we have the replacement, whatever that was. Just also need to pull out these points. Guess we can do like some epilogue or something. Like as an epilogue, take these positions. It's just first 2 points there. Right?
Mhm.
That's supposed to be almost maybe not 1 plus 1 because it's maybe 1.1, or is it 0.5? Just 0.5. Maybe that's one. We just actually highlight the x's because it's not. Then we actually make some proper grid of that. Like matrix plot doesn't work very good. Yeah, let's do this like that. So we have this. Let's put letters too. It's another epilogue. Our data. And we just do how can I do? Does this work? Is it only for lists? There's a way to do it like map supplied. It's not documented yet. Supplied thing. Yes, still doesn't work. I don't know how to use it properly. Don't remember. Let's just do it. Stupid. Stupid. This one. No position. I meant. And then you can. So that the positions of all the letters. I'm going to just put them by hand. Maybe too large. No, that's no. Those are tiny. So it takes a while. Visualizations. Just gonna put it in the center. Okay. So is it correct? The dots should mark all the masses. I think. I think that checks out. It's fun. We just replace points by something much more.
So all the dots present masses and sum.
Yeah, the dots mark all the patterns, right? If you look at any dot, you will find that one of those 4. So it's the middle of those. Again, we just need to replace this point by 2 lines or something, so to make it interesting. So that it actually looks like a cross X, like a giant X. Maybe just put an actual X letter in there. See how it looks like instead of making a line. I put the text X in that position with the default font size. See how it looks like. Can make it larger then. 48, 24. Make it kind of font light gray. That's imperceptible. It's too light. I just draw the lines. That's too thick. I want the actual line. How do you do it? If this is the center, I want one line. There's going to be 2 lines. One is from the center, going that way. Another point is going that way. And another line is going to be basically, oops, point minus here, I guess. Maybe it's too small. Let's do it. Thickness. Make it longer. Square. Oh, that's too thick. But that's the idea. That's Christmas.
Yeah, looks nice.
Yeah.
Too big.
Yeah, I think that's better. Those are all the X's. That's a fun picture. We need more of those for each challenge.
Yeah. Get started.
Well, I guess we are done for today. Nothing else to solve. I'm gonna put this under visuals. Oh, that's some big matter. Yeah, I can't even. I'm gonna use it then. Have one. Yeah, that's fun. Okay. I'm gonna publish this. That's it. Who's still there? I guess thanks for watching, whoever watched that and participated. Maybe
So,
next time we're gonna do not 3, and maybe because they're gonna be harder. Should we do one on Friday when there are 2 new challenges to solve? What do you think?
yes. Two of them. Very
Yeah. No, then till Friday, I guess. Saturday maybe on weekend. Who knows? Thanks.
Yeah, thank you, Dave.
Thank you.
See you all next time.
See you next time. Goodbye.
Okay.